Hi guys and girls, I have a video here going through some exam style questions regarding cones and spheres. I think actually all of these bar one are volume. There is one question here which is related to some surface area. But you're given those formulae at the top. I know it says things to remember, but you're normally given them in the exam nowadays. So let's crack through. We have a storage tank, which is a cylinder with a hemisphere on top of it. And the height is 30, yeah. Okay, that's all labelled up on the diagram. We need to calculate the volume of the storage tank. So we've got the cylindrical bit. And a cylinder has volume pi r squared h. So in this case it's going to be pi times 9 times 30, so that's 270 pi. I'm not going to turn it into significant figures till the end because I'll end up with a rounding error. The hemisphere, well, if it was a whole sphere it would be 4/3 pi r cubed. Okay, it's up there. But we only want half of it, so that is 2/3 times pi times 27, which is 2/3 of 27 is 18 pi, and they're bolted on top of each other, so the volume is 270 plus. My pen stopped working again. Come on. There we go. 270 plus 18 lots of pi. Now I'm going to whack it in the calculator, or you could turn that into 288 pi if you like. Pop it in your calculator now and you get 904.7. We only want 3 sig fig, so 905 is enough. Next question. Okay, we have a sphere of volume 500 meters cubed. Find the radius of the sphere. So we know that 4/3 pi r cubed has to equal 500. So I'm going to multiply by 3 is 1500, divide by 4, and divide by 4 pi, get 375 over pi. Then I want the cube root of that. Calculator. Okay, we get, what does it want it to? Oh, it wants it to 3 significant figures. That's not so bad. It's 4.9 meters, or 4.90 technically. 4.9. Okay, second one. So we've got a clay bowl, 2 hemispheres. Okay, big one goes out to 8.2, small one to 7.7. Nearest 0.1. Find the upper bound for the volume. So to make this volume, that's the volume of clay, not the volume of the bowl, it's how much clay is used. So that gap there needs to be as big as possible in order to get the thickest amount of clay. So that means that the 8.2 has to be as far out as possible. So that's the upper bound. So we're going to use 8.25. And we want to cut out from the middle as little as possible. So instead of using 7.7, we use 7.65 for the lower bound. do the two hemispheres and then take them away. So if it's a full sphere, it's 4/3 pi r cubed, and the hemisphere is half of that, so we can use 2/3 pi r cubed. So we've got the large hemisphere, which is going to be 2/3 times 8.25 pi, 8.25 cubed pi. This does say or indicate that we need to keep it as a multiple of pi, because it's asking me to find out what k is, i.e. what multiple of pi is going to give me the answer. Anyway, that comes out as 8.25 cubed times 2/3. Got 4.125. Why doesn't that feel right? Oh well. 4.12. Oh, I've typed something wrong there, haven't I? Let's try that again. Actually, what I could do is I could do it all in one calculation. I'm going to do that. So I've got the small, which is 2/3 7.65 pi cubed pi. So the volume is going to be the difference between those. So I can write it as 2/3 8.25 cubed minus 6765 cubed times pi. Well, you can work out each one. Actually, I might just quickly work out each one. Just going to pause it, otherwise I'm going to waste time. Right, this one is 374.34375. This one is 298. No, something, hang on. Pause it again. Oh, I was right, it just looked like a too big a number. 46475. So when I take them away, oh, that's pi, and that's pi. So when I do the subtraction, I am going to end up with... I'm going to pause it again so I don't want... I end up with 75.879 pi. So K is 75.879. It doesn't ask us to round it, so I'm just going to leave it like that. It doesn't say 3 sig fig or 1 decimal place, so just leave it. Right, next question. I think this one, when I was looking through, is, yes, this is the only one that talks about surface area. We are talking about the surface area of a cone, which from the top is pi RL, the curved bit, not the base. So we know, what do we know? Well, we need to know the radius. That's easy enough because it's just half of the 10. So we know that R is worth 5. We know that the height is going to be worth 12. So we've got a right angle triangle here. So we can use Pythagoras to find L, which is the slant length. So L is going to be the square root of 12 squared plus 5 squared, which is root 169, which is 13. Okay, so L is 13, R is, so, what am I doing again? Curved surface area. So surface area, curved, is pi times R times L, which is 65 pi. It wants it as a multiple of pi, so I don't need to do anything else. Okay, next one. We've got a radius 5.7, slant of... Okay, so we're going to need to work out the height. We need to find the volume of the cone. Yes, we definitely need to know the height. So again, we've got a right angle triangle. The slant is 12.6, the width is 5.7, or the radius. We need to find h. H is going to be the square root of 12.6 squared minus 5.7 squared. So h is 11.236 ... So the volume is that's a sphere. It's 1/3 pi r squared h. So that's 1/3 times pi times 5.7 squared times 11.236 ... And that comes out as, so I should have paused it again rather than just typing this. Comes out at 382.3221. Oops, it moved. Anyway, we only want 3 sig figs, so it's 382. And the last one, I don't know why this has gone from 4 to 6, but you know, it has. It doesn't matter. What have we got here? So we've got a rectangular tank. I'm going to put the ball into the tank and I need to know how much the volume goes up. Okay, so how much water is in the tank already is irrelevant. Yeah, it's irrelevant. We don't need to know that. All we need to know is how much water is going to be displaced by that sphere, i.e. what is the volume of the sphere. So volume of a sphere is 4/3 pi r cubed, and we have a radius of 3.5 cubed. So that volume is 179.59 ... So that's for the sphere. Now, the height is the variable part, so all I need is to know what the base area is. So I'm going to say, right, if I put that much, that's the volume, and that's the base, how far spread out is it going to get? So I need to do 12 times 11, which is 132. So if the height that it rises, imagine it like that. Oh my lord, that is a terrible drawing. So the height of that water there is going to be the volume divided by the area it's spread over. And that is 1.36 to 3 significant figures. Right, you can go a more convoluted way around that. You could work out how much water is in there now, then add the water in that's displaced by the sphere to give you an overall volume, and then divide that to find the new height, and then take off the 8 that you had before. But frankly, as you can see, this way is quicker. Okay, right, anyway, that is it for today. I hope that all made sense. Catch you later. Bye!